To build our world, we have consumed our world. Our hunger for the rare metals that power our lives has us scarring the Earth. But the most valuable resources are not on our planet, they're in the void. This is the story of the trillion-dollar gold rush in space and the robots we are building for the most dangerous job in the universe. The vision isn't new, but the reality is arriving faster than anyone imagined. We stand at the edge of a new frontier, not one of conquest or exploration, but of raw survival. The asteroid belt, an immense chaotic river of ancient debris that arcs between Mars and Jupiter, is more than a graveyard of stone. It is a treasure vault, a scrapyard of failed planets. And hidden among those drifting monoliths are the shattered hearts of once-forming worlds. These are the M-type asteroids, metallic giants, their cores laid bare. Among them, 16 Psyche looms as a crown jewel, a lumpy, potato-shaped world of iron and nickel, its knotted ridges and sunburnt hollows silent witnesses to cosmic violence. Valued at $10 quintillion in raw material, it floats like a coin tossed into the dark. But it is not alone. Elsewhere, deep-shadowed craters on carbon-rich asteroids conceal glowing veins of blue water ice, flash-frozen reservoirs from the dawn of the solar system. These icy caches could be harvested, purified, and split into hydrogen and oxygen, the volatile ingredients of rocket fuel. A single rock becomes a gas station, a foundry, a launch pad. This isn't just mining, it's manufacturing a future, a self-sustaining human presence beyond Earth, built from the bones of the cosmos itself. So, if the riches are floating above us, why aren't we all driving platinum-plated cars? Because this is no treasure hunt. It is the harshest engineering problem ever posed. First, the physics. NASA's OSIRIS-REx mission gave us a glimpse of what's possible. After navigating millions of kilometers, the spacecraft performed a daring touch-and-go maneuver on the asteroid Bennu, barely kissing the surface to collect samples. It was a triumph of precision and a revelation of chaos. The moment its robotic arm touched down, the regolith gave way like powder. It didn't land, it sank, because most asteroids aren't solid boulders. They're rubble piles, collections of loosely bound rock, held together by gravity and luck, rotating unpredictably in the void. Land too hard, and you don't drill, you rebound, slowly tumbling back into space. Then came DART. NASA's kinetic impactor struck the asteroid Dimorphos with lethal intent, nudging it ever so slightly in its orbit. A proof of concept that we can not only approach these alien bodies, but alter them. But even if we master the physics, we face a second wall, the law. The 1967 Outer Space Treaty declared that space belongs to everyone, and thus to no one. It is a legal twilight zone. Ownership of resources is debated, not defined. Who, exactly, gets to keep the $10 quintillion floating in a metallic core? And so we hover on the threshold, technically capable, legally unprepared. This is where genius begins to break through the silence. Because the solution isn't one elegant machine, it is a swarm of extraordinary ideas. Picture a spider-like miner descending in low gravity, its articulated legs flexing with surgical precision. This is no rover, it's a climber designed to walk, cling, and anchor itself to the tumbling skin of a rubble pile. At China's University of Mining and Technology, engineers have built SCAR-E, a six-legged insectoid robot that rolls across solid ground, then switches to claws for anchoring, its movements like a mechanical ant scaling gravel in slow motion. Astroforge's upcoming Vestry mission takes a different path, using electromagnetic feet to cling to iron-rich surfaces. A magnetic handshake with the void. But when drilling fails, we turn to light. Transastra's radical optical mining system uses a solar-powered laser, a lens of concentrated sunlight, to heat, fracture, and vaporize rock. Imagine it, a beam of sunlight slicing through asteroid stone, cooking it from within, freeing volatile gases and water locked inside. And then, the big catch. For smaller bodies, rich in value, We don't mine them where they float. We bring them closer. Enter the capture bag, a massive inflatable sack designed to envelop an entire asteroid. Once sealed, the rock can be towed gently into Earth orbit for safe, controlled disassembly, like netting a cosmic whale and reeling it in across millions of kilometers. NASA's Psyche mission is already en route to the crown jewel. A robotic geologist flying toward 16 Psyche not to mine it, but to learn how Psyche will be our first blueprint, its scans, its surface, its secrets, all fed back to Earth to train the next generation of robotic miners. These are not just machines. They are pioneers, tireless, fearless, and built to do the most dangerous job in the universe, without ever needing to breathe. The technology is almost here. The legal framework is being built. But what do you believe is the greatest barrier to this new gold rush? The engineering, the cost, or our own imagination? Let me know in the comments. This is more than a gold rush. It's a philosophical choice. By reaching for the resources of the void, we are not just solving for scarcity. We are deciding, as a species, to become interstellar. The path is set. The first robotic pioneers are already on their way. I am the cartographer, and this is the Atlas.